Good afternoon. My name's Ben Waite. I'm a customer group manager for Trelleborg Offshore. I'm here to talk to you today about how Trelleborg are addressing the evolving needs of subsea flow assurance. Myself and my esteemed colleague, Jürgen Sletten, will be leading the presentation today. I'll take the first half where I'll address how we're dealing with improving our existing systems, and Jürgen will take the second half of the presentation to deal with a new development of our Vicafirm system. First of all, I need to ask a question, if any of the audience would like to answer this, but why do we actually insulate? So why do we go to the trouble of insulating subsea hardware? Okay, so the answer is fairly simple. It helps maintain flow rates, it reduces processing costs, and it optimizes productivity. Keep the oil to a certain temperature above the wax and hydrate formation during normal operating services, which is steady state, or during cool down periods due to unplanned or emergency shut-ins to maintain the flow of the oil through the system. The greater the depth of the fields, the more expensive and more tricky it is for intervention should there be a blockage in the system through hydrate formation due to cool down. Okay, so it's been an industry well-known secret that there's been some issues with insulation systems in the past, and in fact in more recent times it's been rather well documented. So how has Trelleborg gone about addressing these issues? Okay, so first of all, we've had to look at our own systems, our own liquid systems in place at the moment, and provide better qualification and improved specifications for those systems. So the materials need to meet greater depths and higher temperatures. So temperatures of up to 350 degrees F and depths of 10,000 feet and in excess. So we've enhanced the existing systems by understanding in greater detail the behavior of our materials. So this is an example of where we are using a liquid system, a polyurethane system for insulation, and we're understanding how the material shrinks using our own in-house FEA analysis. And this has helped us develop field joint and molding to molding joints that are more robust and more reliable. We've gone through a 3-year phase of improved qualifications and improved application techniques. So rather than going into detail of each one of these points, I'll just pick one or two and just give you an example of how we've improved our application techniques. So we've improved the materials and we're improving how we apply them. One element of the application that we've improved is something we've taken from the automotive industry, a procedure we've adopted from the automotive industry to dust check the substrate prior to applying the primers and prior to applying the polyurethane systems to guarantee the bond between the PU and the substrate. We use pigmented primers and extremely long qualification works for each project now. Jürgen will touch on it when he takes over the presentation. However, we've also developed an extrusion process in our plant, which is also mobile. With improved systems and improved application techniques, we've also had to improve our technologies. Our technologies for applying these systems at site to give the customer and the operators more confidence and more ability to be able to check these systems. We have now in place a procedure now where you can real-time record the data and use this to provide a record for each individual moulding. We can do this, gives a mass flow, heat, temperature, densities, flow rates for every individual moulding. This can be all kept for traceability for later on. Moving on. So also, as we've improved technologies, we've improved materials, we've improved processes. But how do we improve the checks on these processes? So Trelleborg now have the option of taking a containerized laboratory to site with us, so we can actually check all the processes at site rather than having to send samples back to the UK. And this is an example of the site here. And then, Jürgen, over to you.
Good afternoon, Jürgen Sletten. What we say now is about the Vicotherm. We've been delivering rubber as a thermal insulation for over 27 years now. But it's still that challenge to go on all the time. We also deliver rubber as fire protection. Using that, it's quite simple because you can prove it through a certification system. When we deal with a thermal system, it's more into qualification. You have to prove every step. We do this by participating in international tests. Some carrying up to 15 months of testing. We do another test going through the physical challenging of it by bending test, carried out both in Scotland and also on the 10 degrees below zero in Trondheim. It's a challenge also toward how can the material stand if it's hit by a troll board. So a special troll board test is carried out where a hydraulic cylinder hits the pipe. In this case we were unlucky because the pipe itself collapsed to the pressure, but still the integrity of the thermal insulation was just good. Using the challenge also where to operate this and how to operate it, we also carried out several tests where we do it below freezing. So this is tests carried out where we see the material act also below freezing. So it increased the window where you can apply the material and use it. So far this material is just barely been launched and we have 20 million in US dollar in order, proving that the material is fulfilling a need in the market. This is another sample because the challenge is then to get out in the field. And this is the first big field installation we carry out as we speak now in Cyprus, where we have a substructure and a buoy, all to be covered with Vicotherm. You can see the challenges of it. It's on site in Cyprus. What we do there is we apply a mobile factory unit where we have the insulation rubber extruded out in the profiles, rolled onto the pipes. We include temperature measuring on it, build it up with a top layer to take the heat and the beating of it, and vulcanize it. Because even though this material has been used for so many years and used normally in our autoclaves at home, to be in the field is no new stuff for us. We've been there through these 27 years, through all the field joints. So when we approach this and see how can we make the field joint more efficient, we approached the way we did it before, where we had basically a precast half shelf and filled it up. By then adding this new method, proven we can save the time a lot on that. So much that we actually said, why just stop with a field joint? Why not take more part of it? And today that's a qualified system that we're using that I showed earlier on carried out in Cyprus today. That means we can get out of the autoclave, out in the field and do the job on site. The newest order we received is Åsegar gas compression field. It's a huge construction that in its size itself leads that we need to use a lot of field application. So the material through the lifetime will always continue to be better and be to fulfill the needs in the customer. Thank you.